Yes, proceed. All with I didn't know that. धन्यवाद.
लाइभ गयो हुन्छ कसले हेर्छ भने अलिक गरिदियो होला हेर्छ अगाडि भिडियो कल यस्तै ठिक हुन्छ यस्तै ठिक हुन्छ बडी चाहिँ यस्तो कस्तो देखिन्छ तिरो हेर नि मिलाएर
Hello. Okay. Okay. Thank you very much for giving me the opportunity to interact with you. It's some of very recent work on AI-based computation and prediction. Time is very short, so I will cover. I think not complete slide. It is available to you. You can go for it. Generic use is there, but two case studies I will come. One is on UNESCO Heritage Sundarban Delta, and other is one of Urban Development Area Kolkata region. So two things are there for analysis and AI-based computations we have done. What is the input? The input is a satellite image. So, who is monitoring the slide? Which one? Okay, fine. So, the first thing is that, so this is my affiliation still now. Mostly you see, as I am talking about the data, how the data we have accumulated and taken is the satellite data. Mostly you see, we have the remote sensing data is a communication satellite. Pointer is here. Hello, pointer is Thank you. So it is a communication satellite normally 36,000 kilometers away from the surface of the earth. But that is not our intention for this today's discussion. We are taking the data mostly red, green and near infrared. These three spectrum we have taken as a data. So how we have taken the data from the satellite image? So multi-spectrum, not hyperspectrum. And what is the location of the satellite? You see, if we go to the communication satellite, it is 36,000 kilometers away from the surface of the earth. But if you think of the satellite where we are taking the data on the earth surface, images of the earth surface, we are taking visible region, infrared and near infrared. These three data we are normally taking, multiple bands we are taking, and then it is a normally polar satellite, and it is you see that passive mode of information. Why passive mode? The thing is that sun is the only source of your energy coming to the surface of the earth through this, and then crossing the surface, coming the features of the surface, then going back to the surface. And these data we are recording. That means you depending on the spectral dependency of a reflector, that means tree, herb, shrub, building, road. So everyone was emitting same frequency. Some absorbing, some. So for that, you see, when we are going for the data, So that data we are taking as a spectral response from that surface, particular. For a particular tree also spectral surface reflection pattern is different. Even nowadays at Sundarban we have around 25 mangroves. Earlier it was 91, more than 91. They depleted. Even the spectral range for different mangroves are different. If you go for NDVI, normalized vegetation index, it -1 to +1 the value. So there is a very specific range towards 1 is the mangrove reflection. So that categorized for different mangroves, and that we are taking as a data. So I think I am able to define the data how we have taken that. And that data containing in the satellite image as a red, green and infrared. So some ratio of infrared and red is called the NDVI. Already I am not going into details. Yeah, this is, you see, some portion is reflected data, some portion is not reflected in various spectral range. So, and these are some of the spectral bands. Normally we are taking the data. Why we are talking about this? The classical stage. Because my data, whatever we have collected, it started from 1975. That is why I am restricting myself. Our computations on neural network based backpropagation network we have used, but we have taken this type of data because of that reason, and we have reached a very good conclusion also. What is that? Normally what we used to, why we have taken the data in different stages. Today I am taking the data, next year same day if I take the data and if I post the data on the same latitude and longitude, I can see the changes. If I change the color of that same place, that means how much change. Suppose one trace of a river is moving from left, suppose 1 meter for 20 years. So if I take today and 20 years after, so I can exactly predict that. And validation is using the GPS. So it's not time is there. Yeah, like that you see that this is normal green vegetation and this is burnt green vegetation for forest fire. You see the spectral difference is there. That means the data containing your image containing the data is different. Today greeneries are here. Tomorrow no greeneries are here. Everything has been burned. That means if we take the tomorrow's picture, it will be like this. And if we take today's picture, it will be like this. So that we have utilized as a data. And we have fed this data into the neural computing system. So this is my background. So based on that, I'm not skipping. Otherwise, you see, yeah, like this. It's very difficult. So, a lot of change directions are there. So we are using AI-based computations. Why AI-based computations? Just I am giving you that. In traditional programming, we have some algorithm and we have some inputs. And we are using a computational system, computer, and you are predicting the output or giving the output. That is a static one. Algorithm plus input to the output. But in machine learning, we are taking some as output data, some as input, and we have a computer predicting the process and procedure. That means based on your criteria. So who will define your criteria? AI cannot define your criteria. You have to define your criteria for your analysis, and for that reason we need the intervention of mankind. So AI cannot interpret all these things, but it can do. It can predict that this type of computation is feasible for this type of data because you are trying to achieve this type of attributes as output. So this will be the algorithm predicting that, but whether this algorithm is feasible for you or not, or this algorithm to be tuned to match to somewhere else using some separate characteristics or the boundary, that has to be defined by you only. So don't say that AI is doing everything. It is a hard labor by a man and machine. So that means when we are using machine learning, that means I don't know the algorithm exactly. I don't know whether my network has been intruded by someone or not. I don't know. My data will say only. So if my data will say something, so who will take the algorithm? Yeah, I will take the algorithm based on my data. Some data as input, some data as output, and some algorithm will be predicted, but then I have to judge it in terms of tuning the algorithm. So that is why again it is a man-machine interactions. So that this is one example that suppose here returns are there, so I need to predict 2. So that means I am giving this as input and I am giving the characteristics of 2 also. So maybe supervised or unsupervised, some as output, some as input. So from there the signature of 2 will be predicted and then it will predict the data. Suppose I have some other set of data, you will find the 2 from there only. That means similar in nature. So that is the model, and that model we have used. Firstly, just I am giving you some glimpse of that. One is that we have taken the data of Sundarban starting from 1975 of Landsat image. It is very difficult to acquire the image, but we have done it, and we have taken the data up to 2018. And we have computed the trend, how it has been changed since 1975 to 2018. Then we have validated with a model, it's called CM-ARCO model, where the error has come between 2 to 4%, not more than that. It's very nominal error in terms of the size of the Sundarban. And then we have predicted up to 2034. And again we have done the validation using the model. So you see, these are the data, 1975, 90, 2000, 2010, 2018, and future prediction is done on 2034. So I will show you some graphs here also later on. So it is, you see that bands I have shown you. So 4 bands for, you see satellite, Landsat 3, you see Landsat 5, 7 bands, 90 Landsat 8 bands of that in 2000. So like that we have taken the bands. So again, it is red, green and near infrared, NIR. Multiple bands are there and multispectral images are available at the satellite. We have taken that data and mostly we have used that, and you see that path and row, it depends because it is a polar satellite. It is rounding around the pole. This is North Pole, South Pole, like this. So it's an angle. And normally, particularly in Indian satellite, I can say exactly that at 10 AM it crosses the equator. It has been synchronized in such a way, and it normally stays only 2 hours. Then it go down to the equator. That means at that time only beta is the backup. So this is the system. And now significance. You see, mangrove forests are the visible in the intertidal region in the UNESCO heritage as your Sundarban. And we have used a back propagation neural network and multiple hidden layers, machine learning algorithm we have used, and we have used red, green and NIR data 1975 to 2018, and we have in the red whatever classification and cluster we have made, that healthy vegetation, unhealthy vegetation, wetland and water bodies. So how it is being changed during for the rise of the sea level and others, that we have analyzed. That we just let's see. You see that water body has been gradually increased from 1975 to 2000. That is one inference. Second one is that wetland has been declined from 75 to 2018. Again, that is not uniform. And you see that net forest area was gradually declined around 6.83% during 75 to 2018. These are given data. It's not my thing, it is data is given by the satellite image we have analyzed based on the neural network. So we have validated this, and nextly you see that what is the validation. Overall 90% accuracy we have got for accuracy, and you see one attribute is there, or what I say that one metric is there, is called the kappa coefficient. For particularly this type of analysis, particularly environmental study and others. So if your kappa coefficient is more than 0.82, That means it is confirming your real situation. It is a strong mathematical model, statistical model rather. So you can read that model. Methodologies are there. So that means with the agreement is more than 0.82. So we have got 0.86 for the validation of the data. And then you see that was the data, and then we have taken the neural network and you have tuned it and you have got the result. Then you have made a model based on the same data, and we have used the cellular automata and Markov model to simulate that same data from 1975 to 2018. Then my model validation is 2 to 4%, only the difference. So for such a large region and satellite image, 2% variation is nothing. And we have computed the area also. That's I cannot go in that deep. So then, as we have validated using a mathematical model, then we have got for it. You see that this is the exact inference from the forest area that I was talking about, the healthy and unhealthy vegetations. That 4 type of classifications we have made during that 1975 to 2018. So you see net forest area increased by, you see forest area increased during this. Maybe that loss due to the natural calamity was less, or some other means are made, but in other cases, you see, I am not going into all details, you can go with. So net forest area increased here, but forest area decreased during 2000 to 2010 is almost 81.08%. Sometimes it is increased in 90s, but because the data is confirming that. Reason is very difficult to interpret because afforestation strategy, natural calamity is less. But I can say that this type of interpretation can be done in that way. So proper validation is very difficult because you see it is a 90 to 2000 is very bit difficult. But in all cases, all types of computations, the Markov model has given the same result. It is a mathematical model. So I am applying my neural network and I am applying my mathematical model. Both are in conformance with the same. So I can say that what we are thinking it is right. This is my validation. So you see that naturally the forest has degraded from 75 to 2018. This is the unique feature. And you see that where the changes have done. So we have seen that, we have clustered it, that mostly on the river channel and outer very nearer shoreline. Mostly on the shoreline. And see, you see, I don't know, we have 3 sectors of Sundarban. The first sector, you can build your infrastructure with a limited way. That means your you can stay there, guest house are there. Region 2, sector 2, you cannot build an infrastructure. So you can go and come back. And sector 3, you can go with the permission of the proper authority. Because that is the core area for your Red Bengal tiger. And only they used to allow in November, December. 2 months they used to allow. You have to take a permission. But otherwise, no road is there. Up to Basanti, I think I don't have that data. That much data I have in my laptop. So I have pictures of that areas also. So you see that we have validated in terms of that. We have gone from there. Only the thing is that up to Basanti you can go by car and then you have to take one boat. Then you have to go. Otherwise, only river channel. So that's along the shoreline, the degradation is more. And you see, most deforestation is done in the period from 2000 to 2000. You see, again, this 1990 to 2000, they are not telling that. The data is telling like that. And the main cause, what is the main cause? What we have thought that transformation to other land, conversion of the land for human settlement, development, slum farms and the agriculture. Most of the cases. And they used to cut the mangrove and they used to go for this type of things that you see that sweet water ponds they used to be made for pond fish and other. So now the prediction. You see, so we have taken the data from 75 to 2018 and we have made a mathematical model, CM-ARCO model, and we have predicted up to 2026 and up to 2036, 2 stages. And what are the prediction? You see that from 2010 to 2034, healthy and unhealthy vegetations will be more lost, whereas the land and water bodies will be increased. So that means rising of the sea level, that's confirming. And some of the island may be more eroded, which belongs to the extreme edge of the sea. That means towards the sea. It's normally. And I think some data was there. Yeah, southern western of Sundarban. This is. You see that up to 2026, it is degradation is predicted around 0.42% per year. And from 2026 to 2034, 0.33%. That means we are taking the mitigation plan. That's why the degradation rate is being arrested. A lot of plan the government is taking for that. So, some suggestions, I think these are the normal things, I am not going into that. So, the monitoring of the forest, use of the agriculture, that is to be monitored properly. And some initiatives of the governments are there, where you see development of national forest parks in different places, they are going for particular. So these are the actual area. You can see that this is the area where we have taken the data, and these are the path, row, and the data we have taken from all of the satellite images, Landsat. So exact data, you see 1975, 90, 2000, 2010 and 2018. We have collected all that data, but you see that fortunately we have got all the data with very hard working of some of my scholars. You see, these are the changes. You see, all the satellite images posted here in terms of the 4 type of classifications. These are the outputs. You see, and the right hand side you can see the what changes is being done for that each places. And these are, you see, mostly you see this is the total forest area is declined. That is the ultimate. You see, 2018 the data, and you see, yeah, other data are also here, that how the changes are. Yeah, you see, this given the legend for the changes. That one type of, that 4 type of category we have taken. So from one category to another category it has been changes. How it has been changes, how much is changes, this given in terms of the picture here, like this. All the data. So if you, these are published in the Art Science. I think you can download that paper from there also. So now another changes, I am just giving you a glimpse of that very quickly. Then I'll just stop it. And here also, you see 1978 to 2000 data of Calcutta, Kolkata urban area we have taken. Mostly we are growing the built up area, and we are just reducing the open land, and we are just reducing the lowland or wetland particularly. So let's see. Let you see that urban built up, open land, vegetation like this. So again we have taken the Landsat data 2, 5, 7 and 8. This Landsat data is available. We have collected, and you see we have taken that data, and multiple spectral band we have taken. So we have classified into urban built up, open land, vegetation, agricultural land and water body. Now see the changes. You see most of the open land converted to the urban built up area. So 9.4%, water body is converted to the open land. That means the water body is being converted by human being. Suppose one pond is here, after 5 years you will see that pond is not there, some land is there, then after 5 years, built up areas are there. So that is 9% in the Kolkata area and 20.97 water body is converted to agricultural land. So mostly you see in the eastern region of Kolkata, they used to convert that. So it's good, but water land is being reduced, which is main, you see, main functionaries for the environment. That you are reducing the open land, you are reducing the wet land, and you are increasing the built-up areas. And you see 9.68 vegetation was converted to agriculture. That means some open lands are there, so as people are coming there, they are trying to go for some agriculture. What they are trying to do. So you see that directional change. During up to 2000, the built-up area towards North Kolkata and South Kolkata, that means towards your Diamond Harbour near sea, and towards the north, that was increased. But after 2010, a rapid increase to the eastern sector. That is, I think Kolkata has converted to Rajarhat, another section of the eastern part, I think. And you see what is the prediction? You see, urban built-up area will be increased by about 9.77% from 2017 to 2019. Again, that means you see 9% is converted from other. How much change is detected? That you see more than, and you see total vegetation loss 17.54%. During 2017 to 2031. So again we have validated that using that model, and then we have got the results that then we have predicted using that model. So same model we have used, and I think this paper was published in, I think, Indian Institute of Remote Sensing. I think they have ACI journals we have almost. So we have to go for sustainability plan. That what is the sustainability plan in an urban area? That is very difficult. The only thing is that your rooftop plantations or your window plantations, this may be done, but who will monitor that? The government will monitor in some ways. So in that way, I think that this is true study of this is one of my scholars' PhD thesis. He has awarded just very recently. And these papers are published, I think, in 4 ACI journals, like Art Science and others. So it is data is taken from there only. So as we have given the copyrights. So I think we should conclude from here because time is not more. Some other common things are there. I am not going to do that. This I think very common. So this is to change detection we have done using mostly this neural computing based systems. And you see that when we have started these neural computing systems, one group of my scholars, I think since 2008 we have started this neural computing. At the time no one was accepting that. We have started at the beginning in terms of wireless communication. So I had one agreement or one MOU with Logitech for wireless communications for the security part. We have gone for that. But you see, when we have started the work in 2008 with some of my scholars in MTech and PhD, so one of accepting these things. But in 2015 and 16, that neural computing system was published by IEEE, and then the policy was published by Google. They have to accept the policy. So we have tried for 8 to 10 years. Everyone was asking the questions, how this will be matching, but now you see everyone is using. We have started these neural computing based systems back to Pakistan and all other in 2008. So from my lab, so all this work has been done in my lab, and still some of the scholars are working on that. Parallelly, actually, my major area is security, but one group of people always work on this remote sensing and GIS-based applications. I think my inception since the North Bengal also one scholar has awarded PhD on GIS. So I think this any questions you can have, I can try to answer whatever your queries. Thank you very much for giving me the opportunity to share with some of my findings in my lab and report it in various school journals. Thank you. Yes, gradually it is being increased. How? You see, rest of the Ganga is there. This is the Ganga, and I think this is around this. This is here. This part is the. And we have one for special distribution map also. You see, 1978 to 2007. How it is extending. You see, north, south, sometimes then towards this red line is showing that towards east now moving more. So we have detected that part also. This is the map that, yeah, this side, particularly this side.
Neural net also.
Yeah.
So we can have question answer session even during one. There will be like a networking session. For you can one next questions, whatever questions that you have, you can ask to the professor even during the lunch time. Is it better?
Yeah, no problem.
And I would like to request Professor K Mandal sir to take the role of session chair from now onwards, so that you have it. I'd like to request you to get the role of session chair from now onwards. Thank you,
I think we have a question on this.
okay.
Good afternoon, respected Professor Dr. J K Mandal sir. My name is Nikhil Chakraborty from Pokhara University. It was an amazing presentation and we had various insights from this, and I had some questions, some queries about this. When we researchers perform our articles, searching our theories, everything, we always have some sort of biasness, we need some sort of control theory, statistical power, or hypothesis to eliminate this bias. And previously, sort asked this question, and I had some similar question to this. You were talking about errors and accuracies, but in neural network and backpropagation methods, we need various more evaluations such as MEPE, MEE, and how can we suggest the government or policymakers, planners about our findings when we have not removed biasness from this? How did you tackle this biasness when image is such a sensitive data and the entire theory of data biasness, data control is, I did not find this there. That is it. Thank you very much.
Hello, thank you. Your very good question. But here you know that when the satellite image is acquired, so actually time is very less. That's why I didn't cover that. When the satellite image is taken, so they are not giving you the raw image. Earlier, during the 90s, we used to get the raw image and we used to remove the biasness of the data. But now it is available. What are the problem? Not only bias, errors are also there. When the light is passing through the cloud, so you cannot take the image for anything. So today you see satellite image is not good. You have to reject the today's image. So this is done by the agency who is taking the data. The first thing. Second thing is that your geometric error, radiometric error, and all the spatial error corrected by the agency, and they used to put the data. Then third thing is that suppose I am taking a data, suppose I have a panchromatic camera, pan camera, the resolution, your normal camera don't have any resolution. It is the pixel density. But in satellite image, we have a pixel resolution. So panchromatic camera normally 5.8 meter cross 5.8 meter. That means 1 pixel means 5.8 meter. So suppose that pixel is 5.8 meter on this some corner of the roof or there. It is called the georeferencing. They used to go for the georeferencing of a 3D mathematical model of that. Referencing model is there. So using that they used to reference that. Then the image may be, suppose this is a square image. So it is rotated like that. So that is also wrong. That is also done by the image means data. So that is also done. Again, the agencies like ISRO in our India, they used to process the data in terms of the image process. How? You see, some spectral ranges are available in one sensor, that is PAM sensor. But if you go to the least sensor, that is 30.5 cross 30.5. So two resolutions are different. So you have to go for the stretching of the image. That 5.8 meter stretch to 30.5 meter. Then they used to blend the image. Again, image processing algorithm bring down to any resolution. So all of these are processed by the agency, and what we are taking all of these processed data. So all are being removed in terms of the strong image processing algorithm and computational techniques. And that's why nowadays it is very easy to put the data without any error and bias. Normally. Because you see here there is no question of bias. What is the reason you know? I am getting a reflection. If it is a tree, I am getting a reflection. If it is a building, I am getting a different reflection. What is the difference? Different in terms of the spectral band. So your rooftop will reflect one frequency, but your tree will reflect other frequency. So that's why I have shown you no spectrum of that. So that is not based on normal computation of the data. It is based on the physical reflection of the feature of the surface of the earth. That is the feature of the earth surface created by God. We didn't create that. But only what is that your sensor is receiving the data. So sensor is receiving which data? Spectrum is separated in band, different band. You have seen it, I have shown you. So if one band is received, that is that type of feature is there. So biasness is not possible here because we have already clustered that in terms of separate sensor. It's not a common sensor. It is a different sensor. Suppose if you study on the vegetation, it is normally 0.6 to 0.4 to 0.9 nanometer, micrometer. But if you go study for your snow, that is different. If you go for study for your ocean surface, the spectral length is different, the spectral distribution is different. So that's why we are sending sensor differently created for different utilities. And you will see that when the satellite is sending, so your satellite is different from my satellite because my purpose of investigation is different than you. That's why I am including some other sensors with a spectrum. That's why bias has already been removed in terms of normal frequencies. And then 10 to 15 types of processings are there. They used to remove all types of errors. We are getting the ultimately corrected image, and only image is taken by the satellite on real-time basis, and rest of the things are completely offline in the laboratory. Nothing else. Everything is on the laboratory. Only the image is taking raw image. Okay? Thank you.
Thank you, sir.